Hello, my name is Piyush and welcome back to 30 days of AWS Terraform. This is day 15. Well, if you have been following the journey since the beginning, give yourself a pat on the back because you have made halfway through the course. We have completed most of the Terraform concepts and we have started doing mini projects now. So in this video, we'll be doing another mini project. It's about VPC peering in AWS using Terraform. So we'll be looking into everything from example perspective. We'll be looking into a brief introduction of what VPC peering is, and then we'll try to implement it in AWS. We'll be doing some prerequisites as well. And so make sure you watch the video till end, and not just watch the video. Make sure you do the hands-on by yourself and make sure you complete the task given in day 15 folder of the repository. Because if you don't do the hands-on, if you don't practice it yourself, it won't be of any use. You'll be just watching the video and there will be no learning for sure. So make sure you do that and do subscribe the channel if you are new here. And I have also noticed that 70% of you are just watching the video and not subscribing the channel. Please, if you are one of those, please try to subscribe the channel. It's free and it helps us grow further, and I will be able to publish more wonderful content like this and many more upcoming series. So support me and I will support you. I mean, I will definitely support you. Even then, even if you don't subscribe, I will still keep publishing videos, keep publishing full courses like this. But if you want to support, feel free to do that. And let's start with the video. So let's understand what VPC peering is. Okay, so let's say you have two VPCs. Now, I'm not going deep into the concept of what a VPC is, what subnet, internet gateway, route table, all those AWS specific networking content. If you still want to check it out, so you can go to my channel and look for two videos. I will share the link in the description. The first video is about calculating IP addresses in CIDR range. That's really important for this video. The other one is about AWS networking. So it will have all the concepts related to VPC, subnet, internet gateways, and many more. So make sure you understand those concepts before you actually try to implement VPC peering. Now, let's suppose you have two VPCs, okay, and this could be in single AWS account, this could be in multiple AWS account, and you want to connect these VPCs together. Now, why would you want to connect these VPC together? Because you have some data. Let's say you have a web server over here and a backend over here. Now you need to connect these two. You need to get some data from the backend that resides in another VPC, or you are sharing some resources between multiple VPCs, right? So you need to connect it. If you don't have VPC peering, you have to do the connection over internet gateway like this, right? So it will be going through an internet gateway if you don't have the VPC peering connection. Now we don't want to do that because we want to keep the connection secure so that the instances can access each other privately as if they were in the same AWS network. And that's why we do the VPC peering. So what we do is we create a VPC peering connection, and this connection has to be bidirectional. That means we create the connection from A to B and then we do the same from B to A. If any of these connection is broken or if you have not connected, the peering would not work. It has to be bidirectional. Okay, and then we create a lot of configuration changes, and I'll walk you through in the detailed diagram. This is just a high level overview of what we are doing in this video and what a VPC peering is. Now, the other important thing to remember is the CIDR range of VPC. It should not be overlapping. That means the primary should not have the same IP range as the secondary IP range. Okay, so as you can see, this is 10.1.0.0 and this is 10.0.0.0. Again, I would highly recommend watching the CIDR calculation video because only then you will understand this concept of what will be the starting IP, what will be the last IP, what do we mean by /16 subnet mask, what do we mean by /24, and so on. So make sure you watch that video. Let's understand what we'll be doing in this video. So that's a low level diagram, a more detailed version of what we'll be doing. We'll be provisioning two VPCs, one in US West 1 and one in US East 1. So different regions, and this will be of IP range 10.0.0/16. The secondary will be 10.1.0.0/16. Now each of these will have EC2 instances with Nginx configured. There'll be security groups through which we can SSH into these instances, and then they will be part of subnets in their respective VPC. So we'll be creating subnets, we'll be creating route table, internet gateways, and finally the VPC peering connection from A to B and B to A, and then we'll also associate the VPC peering connections. Now we'll be doing all of these, but if you have understood the first part of this video where I explained why do we need VPC peering, you will have a question: why are we using internet gateway if we were to access these instances privately? And you're right, we should not be doing that. But I have left this as an assignment for you. Okay, so I'll be still using a route table with internet gateway configured as the destination, but this is not what we should be doing for VPC peering. So what you need to do is, I have added the details in the GitHub repository as well and over here as well. So what you need to do, you need to update the route table to connect the VPCs privately. Okay, and then you also have some more assignment tasks like add additional VPC C and try to connect VPC A and C, understand the issue, fix the issue, and then simplify the code using more variables in Terraform function and harden the security by allowing secure SSH access. I have intentionally left some loopholes in this project so that you can practice by yourself, so you can fix it and understand how it actually works and how it should work as per the best practices, right? So I have left it for you. And yes, before that, understand one more concept. So there is a concept of transit peering. Okay, transit peering. What do we mean by that? Let's say in this particular diagram, you have two VPCs, right? If we were to expand this further, and if I were to add additional VPC, let's say I'm going to use this, and let's call it another secondary VPC with a different CIDR range. Let's use 192.168.0.0. Again, it should be non-overlapping IP range. Then we have another subnet in this range. So let's make a copy of this as well, and let's call it subnet C. Okay, subnet name can be same because they are in a different VPC, so it could be same, but just for the sake, I'm just keeping the name as separate. Now let's say if you want to connect VPC B and C, so what you can do, you can create a VPC peering connection between B and C, right? And again, it has to be bidirectional. So let me just remove this arrow for the simplicity, right? Now you have created a VPC peering connection between B and C as well over here. So these can be connected together like this. Okay, but if you have noticed it, we are creating connection between A and B and B and C, but we have not created the connection between A and C. So would it work, this connection between A and C? It will not work, and that's the assignment for you, because this is called transitive peering. Sorry, my bad, it is called transitive peering, and transitive peering doesn't work. So in order to connect two or more VPCs, you have to create VPC peering connection between each of those. So A and B, B and C, and then A and C as well. So that is why with this approach, if you were to connect instance in subnet A to subnet C, this will not work because you have not created the VPC peering connection between A and C, right? So this has to be created as well. So that's what I have given it as a part of assignment. So actually I wouldn't have told you that because I wanted you to figure it out yourself why connection between A and C is not working. But anyways, now you know the concept transitive peering, and now you know how to fix it. Now it's up to you to fix it. All right, so let's go ahead and let's start with the demo. Okay, that's my VS Code. I'm gonna make a copy of the previous day folder so that I'll have some baseline code. So day, oops, let's go over here and let's copy day 14 with day 15, and let's go inside day 15 and now this, let's go inside day 15. All right, so I'm over here main.tf. I'm gonna replace everything, so don't worry. We'll start with provider.tf. Okay. So if you remember when configuring provider file, I have told you that we are locking a provider version, let's say version 6, or like you can use any provider version. And like I have explained it very well, why do we need that? But till now, we were using only one provider and we are using a default region for that provider. If we were to lock to multiple regions, we can create multiple provider and refer it through an alias. So how do we do that? Because in this demo, we'll be creating resources is multiple availability regions, right? US East 1 and US West 2. So for that, we can create separate providers and we can just access it by the alias. So what we can do is provider AWS, that's cool. Then region is you provide your primary region, which is US East 1. And then you can use alias and give it a value. Let's call it primary. Similarly, you can do for secondary as well. So US West 2 is our secondary region, and let's use the alias as secondary. Okay, so that's your provider version. Let's lock in for version 5.0 because this is what I have used for testing. Okay, now go back to variables and let's create the variables. Okay, so let's call it primary is US East 1, and let's create another variable and let's call it secondary. Okay, secondary is US West 2. Now we can just directly use variables inside our provider. So alias is var dot primary, and over here is var dot secondary. Okay, so that's done. Now I'm just gonna remove everything from main.tf and let's move ahead with what we are doing. Okay, so I'm gonna paste code snippets one by one, and I could have written everything, but if we do that for every single demo, this series will never end because there is a lot of code snippets that we'll be doing. But I will explain whatever we are doing for the first time, and rest because we have already covered it, I'm just gonna walk you through it. Okay, let's start with generating the access keys first because we will need to access the instances. We'll be SSHing into the instances, so let's create two access keys. And I have given the instructions in the GitHub repository, so don't worry, but this is the command I'm gonna use. AWS EC2 create key pair name, and then provide the region. The region is US East 1 query, and then output it to a PEM file using which we'll be accessing it. And let's hit enter. So this is for US East 1. And if you are on Windows, I have provided instructions for Windows as well. Like because after creating the keys, you have to grant that to a certain permission, like it has to be 400. So let's do that for the other as well. So now we are doing for other region, US West 2. Okay, and here's the key. These keys have been generated in the same directory to provide the permission. So chmod 400 star.pem. I'm providing 400 permission to the key file. Like this is what it has to be. The SSH key has to be with 400 permission. Otherwise, it will throw you the permission denied error. Okay, now let's start adding details to main.tf. So first we need a primary VPC in US East 1. Okay, so you can just go to Terraform documentation over here and search for AWS VPC. That should be the resource name. Let's put that in double quotes so that it will find the exact string. AWS VPC over here. And what we need, let's use this one. Okay, basic usage with tags. Let's go over here and let's paste the code over here. Now AWS VPC, let's call it primary VPC. CIDR block, it's better if we use the variable for that. So let's use the variable. Plus we need to provide the provider detail because we have configured separate provider for both the regions, right? So var.primary, that was the provider. Now it says no declaration found because it's not a variable, right? It's provider. So we have to access through the syntax AWS because the provider is AWS dot primary, which is the alias. Now let's keep it default, or you can remove the instance tenancy. We need CIDR block. So let's go over here in variables.tf and let's remove the extra ones. Oops. Um, let's keep only the first three. The third we just added, and let's remove the rest. And let's create another one, variable, and let's call it primary CIDR block or primary VPC CIDR, just for the sake of simplicity. Okay, and let's give it a default value, and we're gonna use 10.0.0.0/16. Now it will be of type string because it's a string, but if you don't set it, that's okay. If you don't specify the type, that's okay, it will take by default. Now that's primary, and the secondary is, let's give it secondary. And if you remember, what we have selected was 10.1.0.0/16. Okay, so that's primary, that's secondary. Let's go back to main.tf, and that's primary one. Now we need to add a few more values, and you can check it from the documentation as well. For the VPC peering to work, we need to enable the DNS hostname and DNS support. So enable DNS hostnames is equal to true, and enable DNS support is equal to true. Okay, so we have provider CIDR. Let's remove this, and then we have tags. So tags, you can add name equal to, let's give it something like primary VPC hyphen, and then we can add the region to it. So I'm just gonna use string interpolation over here, var.primary region. Okay, do I have this variable over here? Let's check it out. Oh, it's just primary. Okay, so let's give it primary. Let's keep it the way it is, primary, var.primary. Now we can do the same. So this is for the primary VPC. Let's do the same for secondary as well. So I'm just gonna copy this block and change the name over here, secondary. Oh, I did not change the CIDR block. Let's do that. var.vpc primary VPC CIDR. Okay, and over here should be var.secondary VPC CIDR. Provider is AWS.secondary. This is true, and over here the name would be secondary VPC and var.secondary. Cool. So that's the first one. Now the next resource is, so we have created the VPC. Now let's check it out if it is throwing any error. So I'm gonna set the alias and tf init. Will initialize the backend. Oops, it is throwing the error unsuitable value on provider line 17, and it is only throwing for the secondary one. Maybe we did something wrong. Let's see. So it says var.primary, var.secondary. We did not create the variable or what? Let's see. Primary is there, secondary is there, US East 1, US West 2. This is good. And if we go back, provider is AWS, and the second provider is also AWS. _primary, _secondary. Actually, I made a mistake. Yes, this should be alias equal to primary and alias equal to secondary. I have provided the same details over in both the places, right? So let's make the change. So it should be this, alias should be this, or you can create a separate variable if you want, but I don't feel a need for it. And over here you use the variable. So primary region and _secondary region, which is this. Okay, and let's run the tf init again. Okay, now it says could not retrieve the list of available version for provider. Log provider must use the Terraform tool. Okay, because we were using Terraform provider 6 till now, and now we have logged into a previous version, so it is throwing the error. We need to upgrade or downgrade to the provider. Okay, so let's switch it back to 602, and if we face an issue, then we'll figure it out. So this should work now. Okay, and let's run tf-plan as well. Okay, now it says first bucket has not been declared in the root module, which is locals.tf. We are not using it anymore. It's better if we just remove this. Oops. Okay, and let's run tf-plan again. Okay, now it says we have two warnings because there are some variables that has not been declared, but that's okay. We are still updating it. Okay, so it says two VPCs will be created, VPC secondary and VPC primary, with the details that we have provided. So we are good till now. Now let's go back to our main.tf, which is okay, over here. Now we have created two VPCs. The secondary is we'll start with creating the subnets. Okay, so I'm just gonna copy the code from the GitHub repo and I'm gonna paste it over here. Okay, so resource AWS subnet, which is primary subnet, and provider is AWS primary. VPC ID is AWS VPC, and primary VPC, is that the name that we have used? Yeah, primary VPC.id, because subnet has to be associated with the VPC, so we need to provide the reference. Then CIDR block, which is var.vpc primary CIDR, or what was the value? Let's see. It was yeah, primary VPC CIDR. So let's go back over here and let's make the change. Now availability zones we are taking from a data source, so we need to add the data source. What we are saying, like availability zone should be taken based on the region that we have used. Okay, now we are not hard coding the availability zones, we are just selecting the value of availability region. Okay, and based on the region it should select the first availability zones. This is a list. Okay, so let me add the data source as well. Just give me a second. So I'm just gonna paste all the data sources. What else do we need? Let's have a look. Is there a file for data.tf? I don't think so. So let's create another file in the same folder and call it data.tf. Okay, now it will have a data source for availability zone for the primary region, and then the data source for secondary region. Then we are using a data source to get the AMI as well from primary region, and this is, we have discussed it earlier, right? How do we check? So we are setting the provider, we are saying get the most recent version of the AMI, and owners is this, which is for Ubuntu. And these are the filter that we are using. Like name is like this, with a star as the regex, and then filter it with where virtualization type is HVM, where architecture is this, right? So that's for the primary, and for secondary as well we are doing the same. Why we are creating separate data source for primary and secondary? Because the AMI ID could change based on the availability zone and region. Not from the zone, but for availability region, it could change. So that's why we have to create it separate. Now we have created that. Let's go back to main.tf, and this is what we have used. So data.aws availability zones primary dot names and 0. Okay, why this 0? Because we get multiple values from this query, right? So when we have a data over here, and if you can see, it will get all the images with this owner and with these filters, but we have to select one of those, so that's why we are using 0. Okay, the index element. Now map public IP on launch is true. That means we are making the instances available over a public IP. Okay, we need that as well. Now over here you can use the tag, which is primary subnet, and var.primary should be good. Environment equal to demo. That's okay. That's for the primary subnet. And the same way we can do it for secondary as well. So let's just make a copy of it. Okay, and primary, secondary. Now provider is secondary, and the VPC ID is also secondary. Secondary VPC secondary VPC CIDR. CIDR block is again this one, and it has to be .id as well. Oops, what did we do? VPC primary VPC. Oh, this not CIDR. VPC.id. Okay, and availability zone should be data AWS availability zone and secondary. That's good. This is good. And over here, let's update secondary and var.secondary. All right, now let's just, for the safer side, run tf plan again. Oops. Okay, yeah, it is fine for plans to add. Now let's move ahead, and the next is we're gonna create a resource for internet gateway. Okay, so I'm gonna use resource, and name is AWS internet gateway, and let's give it a name. Let's call it primary IGW. Okay, so let's give it the provider details. Provider is aws.primary, and VPC ID, because we have to associate internet gateway with a VPC, right? So VPC ID is AWS VPC.primary VPC.id. Okay, and let's just add the same tags that we have used for, let's use these ones. Okay, and I'm gonna make the change over here. Instead of primary subnet, let's call it primary GW var.primary, environment is demo, and let's make a copy of it to make it for secondary as well. Okay, so secondary IGW AWS.secondary. Instead of primary VPC, secondary VPC dot ID. Over here as well, secondary, and over here as well, secondary. Okay, so now internet gateway has been configured. Now what we'll do is we'll create the route table for primary and secondary. So I'm just gonna copy paste it over here. Okay, so what we are doing over here, let's see. AWS route table is the resource, primary RT, provider is AWS primary, VPC ID is what we have used over here. And then we have CIDR block. So this is the destination, right? So we are providing a gateway ID, which is for internet gateway, and we are setting the route to 000. And this is what you need to work on, right? What I've provided as the part of the assignment. Then we have tags. We can call it primary route table, or you can append the region as well along with it. And then environment is demo, and the same way we are using for secondary as well. So let's run tf plan again. Okay, I think it's working fine. 8 to add. Yeah, it's fine for now. Now we have created the route table, but we need to associate that route table with the subnet as well, right? Otherwise, that route table won't work. So for that, we'll create the resource AWS route table association, and let's give it a name, primary RTA, right? And let's give it provider. Again, if you are worried like where I'm getting these details, like what details are we adding, what all the attributes are we using, you can check the documentation because I have done it once and I'm aware of it. So you can check over here as well. See route table association over here. See VPC ID, route table ID, and then we have region as optional, provider because we are using multiple providers, so you can add it. Yeah, so these are the details that we need. Subnet ID, route table ID, VPC ID if you are using any particular route table of a main VPC. But we don't need to do that over here because we are setting the provider and we are associating the subnet directly. So that's good. Okay, so provider and then subnet ID is equal to AWS subnet. Did we create the variable for it? Maybe it's there. Let's see. Oh, no. This is the subnet that we have created. Okay. So AWS subnet that we have created, ID from there, dot primary dot subnet ID. Okay. And now the route table ID, because we have to associate route table with the subnet, right? So route table ID is equal to AWS route table and dot primary. Okay. So this is the route table association. The same way we have to do it for secondary. So route table association, instead of primary, let's use secondary, and provider AWS subnet primary subnet secondary subnet dot ID, and instead of primary RT, secondary route table. Okay, so this is done. Now let's run TF plan one more time, and okay, now it is throwing the error. So let's see what it is. Inappropriate value for the attribute route table ID in line 111. Okay, so it has to be the route table ID. Over here we have also used the primary RT. So dot ID. Dot ID. Okay, so let's run it again. Okay, now it's better. 10 resources to add. Okay, now the next is we need to create VPC peering connection from both the side, from A to B and from B to A. Okay, so I'm just gonna copy the code over here. Okay, AWS VPC peering connection from primary to secondary. That's why we are naming it that for the sake of simplicity. Provider is AWS primary, VPC ID, peer VPC ID, and peer region. So peer VPC ID is the destination VPC ID. Okay, so this is mandatory. When we are initiating a connection from source to destination, this is the source VPC ID, this is the primary VPC ID, but we need to provide the secondary VPC ID as well, right? If we are going from A to B, we know where we are, but we need to also know where we want to go. So this is where we want to go, to the secondary VPC. Then peer region, we need to provide where that location is as well. So var dot secondary is the variable, auto accept equal to false. Okay, and then we have tags. That's okay. Now do the same from B to A, otherwise as I've told you it will not work. So let's call it secondary to primary, AWS secondary. Let's copy this here, secondary VPC ID, and over here now VPC peer ID will be primary VPC over here, because now the destination has changed. We have reached to the point. Now we need to come back from B to A, right? So that's why we need to provide the ID of A, and now the source will become the secondary VPC ID. Okay, peer region is where dot primary. Okay, and we can call it secondary to primary VPC. Okay, so this is also done. Do we need anything else? Now we need to add routes as well in primary route table and secondary route table. Okay, so let's add the route. Okay, so what we are doing, we are providing similar details: route table ID, destination CIDR block, which is secondary VPC CIDR, and VPC peering connection ID. So we are saying go from primary to secondary, and this is the route that you have to follow, right? And it's dependent on, so we have created an explicit dependency on the VPC peering connection. Okay, AWS VPC peering connection acceptor, which is the secondary one. So there is a requester and then there is an acceptor. Okay, actually we just need to change the resource name. Yeah, so the secondary to primary, the resource name should be AWS VPC peering acceptor. And over here wait, let's call it secondary acceptor. Provider is same. We need to provide VPC connection ID and auto accept equal to true. So if you remember, in the primary connection, we have set auto accept equal to false. But over here, we need to provide auto accept equal to true. Only then the connection will be established. Okay, and this is good. Now the second is AWS route primary to secondary is configured. Now we'll create the same route for the secondary route table. So what does it have? AWS secondary, route table secondary RTID, a destination CIDR block, which is for primary, and VPC connection ID. Okay, connection ID of the primary to secondary. Okay, the rest is, I'm just gonna paste everything together because this is something that we have seen before as well. So rest is about the details of EC2 instances, like EC2 instance and the security group associated with those as well, right? So from here we'll be making some changes. Okay, so AWS security group, primary security group, VPC, and now we are using SSH from anywhere. This is something that you need to secure. Okay, so make sure you follow the task and secure that from your IP or a particular CIDR range. Then we are saying let it do ICMP from secondary VPCI, because this is how we'll test the connectivity by ping. So we are enabling the ping protocol as well. And also we are saying all traffic from secondary from port 0 to 655.535, because Nginx will run on one of these high ports, right? So we are enabling that connection, and outbound is okay. Then the secondary resource group, similar in the secondary VPC as well. We are opening 22 port 22 and ICMP from primary. Okay, and also all traffic from the primary VPC. Okay, and then these are the detail of EC2 instance. So var.instance type, our instance type in the variable. So let's add it, and we need to add the primary key name as well. So I'm just gonna paste something. Wait. Okay, so let's go to variables over here. So we have primary, secondary, primary VPC CIDR secondary. We did not add the variable for subnet as well, so let's add it. So primary subnet is this /24, secondary subnet is this /24. Instance type we are using T2 micro, and let's pass the primary key from TF-vars. Okay, or you can pass it from here, like doesn't matter, like it does matter, but yeah, or you can pass it from the environment variable. Okay, so let's go back. This is good now. var.instance id, primary subnet id, and then we have to provide the user data. So this user data comes from a local. This user data will have the Nginx configuration. So what we are doing, user data, if you have worked with AWS before, this is the user data script that get executed once the instance starts, right? So it will have a file, and we need to create that file in the local.tf. So let me just copy that as well, and in the local.tf add it over here. Okay, so what we are doing apt install, apt upgrade, and then starting the Apache 2 server, and then just printing the primary VPC instance ID. So let's use the var primary, var.primary, and it is creating an index.html with the VPC instance region as well as the private IP of that region. And similarly, we are doing it for secondary as well. Okay, let's go back over here. Primary is done, secondary is done. Now let's change the region over here as well in the tag, and over here as well. Now it says these resources are dependent on the VPC peering connections. So this looks okay. Now let's run tfplan. Okay, 18 resources to add. So let's hit the apply now. Approved, hit enter. So let's see if it throws any error. We'll try to fix it. If it doesn't, I'm just gonna pause the recording. Okay, so let me pause the recording, and if it throws any error, then we can check it. Okay, so it is completed, but I forgot to do one thing. I did not add the values of the keys, right? So let's add it over here. Let's move the instance count, and let's add it primary key name and secondary key name. If we apply the changes now, it might recreate the instances. So let's see, because in the default the value I kept as blank. So yeah, it says to add. So what it is doing, it is destroying the instance, modifying the route table, destroying the secondary instance. So it will recreate those instances, but before that, first it will destroy and then it will create. So let's wait for it. I'm gonna pause the recording. It is throwing some error related to the key pair is invalid. It says key pair does not exist. So let's check it out. The primary key name is VPC peering demo east, secondary is VPC peering demo west. And if we check over here, so there is a name mismatch. So let's fix this one. The name is demo east. Okay, and let's verify the main.tf as well, where we are using the keys. Key name equal to var.secondary key name, and it is getting okay. That's good. Now in this, it is primary key name. Okay, and over here, primary key name and secondary key name. This looks okay. Now, are we using anywhere else? I don't think we were. Primary key name. Yeah, so that's only at one place. In the TFR we are using, and in the variable we did not provide anything. So let's see. Yeah. Okay, so let's run it again. It was throwing error for both the keys. Why only one name mismatch was there? Let's see. Okay, still it is throwing for both. It says, let's debug this error. It says route created, now creating EC2 instance operation, status code 400, API key invalid key pair, VPC peering demo east does not exist, and VPC peering demo west does not exist. Okay, so are we creating the same name in the same regions? Let's see. So primary is demo, which was supposed to be east 1, and this should be west 2. So let's check in our AWS if the keys were indeed created or not. So let's go to EC2, and this is US east 1, and let's go to key pair over here. We don't have the key. I remember creating it in the beginning, right? Why still we don't have it? Let's check it out from here. Oh yeah, it was created. That's why the values are over here. Check the command we used. Oh, I think I know what the issue is. So you see, this is the command that we use. We are saying create key pair with the name VPC pairing demo. Okay, and we've used same name in both the commands. It's just we are using it for different regions. So the name will be this. This is just the file name, but the key name is VPC pairing demo, which is over here. So if we check VPC pairing demo, so this is US East 1. If we check in West 2, we will have the key with the same name, VPC pairing demo. Okay, so this is the name we should be using. My bad. Okay, so in primary and secondary, we can use the same value. Okay, now it should work, I promise. Auto proof. So let me pause it one more time. Okay, it says it is completed. Let's check the resources. Okay, so let's check if the instances are running. We have one in US West 2, and we should have one in US East 1 as well. Okay, it's there, primary VPC. Now we need to check the VPC peering connection. So go to VPC and let's see peering connections over here. Now it says primary to secondary connection is active. Okay, requester is this, acceptor is this. That's good. Acceptor region is US West 2. So here are all the details. Here is the DNS. It says private IP address disabled. And then there's the route table. It doesn't have any route table. Okay. And let's go back to US West 2. Okay, over here it's secondary to primary, and this is also active. Requester and acceptor. Okay, requester region, acceptor region, everything looks good. So now let's log into the instances and let's try to check the connectivity. Okay, so I'm gonna go to EC2 and let's create a duplicate tab. So this one, let's switch it to US East 1 and go to instances. That's the secondary VPC. Just try to log in into that. Connect using a public IP. Okay, we can use instance connect. Okay, I'm logged in, and let's use the same method in primary instance as well. Hit connect and connect. Okay, so let's increase the font. Now let's try to ping. So this is the private IP of this instance. Let's try to ping this instance from the other. Ping. Okay, it's not working. Let's try with the public IP. So ping this one. It doesn't seems to be working. Let's check curl. So ideally the curl and ping should work on the private IP. Maybe it's taking some time, or let's try it again. Okay, so this is the primary VPC. We are trying from primary to secondary. Let's do the same in secondary as well, which is this one. So now I'm trying to ping from secondary to primary. Okay, this is also not working. I'm not getting any reply. And how about curl? Let's try the curl again. Curl HTTP. Okay. Yeah, this is not working. So let's check if we have configured everything correctly or not. Okay. Let's go to instance and we need to verify the route table, security group rules, and so on. So this is secondary. Okay. So this is secondary. Let's go to security. And over here we can see in the security instance, source is 10.0.0, which is for the primary VPC. So we are allowing all ICMP traffic and we are allowing all traffic on the high-end port. So port 80 or 8080 should also have worked. It's not working. Let's check the other instance in US East 1 as well, which is over here. EC2. Okay, and over here, let's go to security. Inbound rule, it says ICMP is working. This is working from the secondary VPC. So that should also be fine. And we have outbound rule as well. So this is fine. Now let's go to VPC and check the route tables and its association. So VPC in both the regions. Okay, and let's check the VPC over here, which is this one, primary VPC. Or do we have an overlapping? Oh, maybe that's why, you see. Maybe that's why, I'm not pretty sure, but there is overlapping IP addresses. So there is already a VPC with the same IP address range. This could have created the conflict. I'm not sure, but let's try to delete this one. Okay, let's call it delete. Okay, this is done. Now let's go back in this region as well. Yeah, there is no conflict over here, so this should be good. Now let's verify before we test the connectivity. So we have secondary VPC. Secondary VPC is associated with secondary route table, which is then going to secondary internet gateway. Okay, and if we check the CIDR, which is associated, okay, and let's go over here. Let's check the resource mapping. Oh, not this one. We need this one. So primary subnet is this, and then there is a primary route table which is going to primary internet gateway. Okay, let's do it one more time. Yeah, still not working. Let's check ping, and over here as well. Ping. No, still not working. So let me check it again. Okay, so what I did, I actually recreated the instances. Why recreated the instances? I just applied the changes again because I deleted the VPC. So we need to maybe refresh the route table. That's what I thought. I'm not really sure if it's gonna work. I'm just gonna test it out now. So I've just applied the changes again. But why did it force the recreation? I will tell you the reason, and you can check it also from here. Even if I am applying the same configuration again, it should not recreate the resources, right? But why did it recreate if I apply it? It's because, let's scroll it further up and you will see the reason. You see where it says forces replacement. What forces the replacement? The AMI. The earlier AMI was this, and now this is this. It has been changed. Now, why it has been changed? Because we are using, if you remember, in our main.tf where we were specifying the AMI, the data source actually. So go to data. So you see we are getting the AMI ID from multiple filters, right? This one, this one, this one. So it would have returned multiple results, and from there we are choosing the most recent one. So this number, this ID could change on the next run as well, right? So that's why it forces the replacement. Now let's go ahead and check. What I need is private IP from secondary instance over here, and let's go to this one. This is the primary one, right? So let's do a ping. Okay, it's working now. You see, now I'm pinging secondary from the primary, and let's do the same. Let's take the primary IP and ping it from the secondary. So ping. Okay, this is also working. Now let's do a curl on the same. Okay, it says this. Primary VPC instance is US East 1, and this is secondary, as you can see, and it says primary VPC instance is this, private IP was this, which is what we ping. And over here as well, if we do, instead of ping, if we do curl, okay, it is returning. Basically this is what we have added in our nginx index.html. So it is just rendering that web page with the details of the other instance. So this is how VPC peering works with Terraform. I'm sure you would have a great learning experience. Don't forget to destroy all the resources. VPC is free of cost, but it could create conflict in the further videos, as you can see. Like what did happen in this case, because there was an VPC already existed with the same CIDR range, and that's what I meant by overlapping IP addresses in the beginning of this video. Okay, so that's one thing to remember, and this is how we do the troubleshooting. We check the security group, we check the route table association, VPC, and all those things. Now make sure you complete the assignment given in the day 15 folder of this repository. Otherwise you will lose most of the context. And yeah, I mean, we all are here for a good learning experience, right? So that you can apply this learning in your day-to-day job, or you can apply this learning while preparing for the interviews and so on, right? So I'm sure it will be helpful. If it did, gives it a thumbs up, comment, and share with your friends, colleagues, whoever. Help me spread the word, and subscribe the channel if you haven't. I will see you tomorrow with the next video with day 16. Thank you so much for watching. Happy learning.